Today we will be solving this question where we have to compute the limit of the function log to the base e of x whole to the power 1 divided by x when x tends to infinity. There are two things to be noted here. First, that in the base of log we have e, that is, it is a natural log, and I will be writing this as ln x. The second thing to note is that in the power or in the exponent we have 1 divided by x, which is a variable, that is, it is varying with every value of x. If x takes the value of 2, it becomes 1 by 2. If x takes the value of 3, it becomes 1 by 3. So it is varying with every value of x. The trick when you are dealing with the variable exponents is that you have to follow a two-step procedure. That is, step 1, where you take the natural log of the entire function. Note that here we are taking natural log because in the question we have natural log. And the second step is you have to raise it to the exponent of the exponential form. So what these steps are trying to say is that if you have a function of the form x to the power y, where x is also a variable and y is also a variable. So first step says that you have to take the natural log of the function and then you have to raise it as the exponent of the exponential function, that is. So your function now becomes the exponent of the exponential function and then you are able to solve it. Note that this transformation does not change your original function because this and this gets cancelled by using the property e to the power of ln a, where a is any function or a constant, that does not matter, which is equal to a. So our function was limit x tends to infinity ln x to the power 1 by x. Now doing the first step where you have to take the natural log, that is limit x tends to infinity ln of ln x to the power 1 divided by x. Now using the property of log x to the power b is equal to b ln x. Using the same property, this can be written as limit x tends to infinity 1 divided by x ln of ln x. Now moving on to the next step, which is you have to raise it as the exponent of the exponential form, which would give us e to the power limit x tends to infinity 1 divided by x ln of ln x. This is a final expression and we need to find the limit. So let's first work with the exponent. Your exponent is of the form limit x tends to infinity 1 divided by x ln of ln x. If you substitute the limit, then you will notice that this takes the infinity by infinity form. That is, if I substitute infinity instead of x, then this expression becomes ln of ln infinity divided by infinity. Now ln of infinity is equal to infinity, so this would give me ln infinity divided by infinity, and again ln of infinity is infinity, so this would give me infinity divided by infinity. And whenever after substituting the limit, if you observe this kind of an expression where you get infinity by infinity or 0 by 0 form, then you are supposed to use the Hopitals rule. What this Hopitals rule says that if you have to find the limit of this expression and this takes the form 0 by 0 or infinity by infinity, and your x tends to your a or real number or negative infinity, in these cases your limit of x tends to a fx divided by gx would be equal to limit x tends to a f prime x divided by g prime x, where f prime x and g prime x are the first derivatives with respect to x. So what this rule says that if you see the form of 0 by 0 or infinity by infinity, then you have to differentiate your numerator and also differentiate your denominator and then put your limits. So using this definition, we knew that our exponent was of the form limit x tends to infinity ln of ln x divided by x. Here your fx is ln of ln x and your gx is x. So according to this rule, you have to first differentiate your numerator and then the denominator. So this would become limit x tends to infinity differentiating with respect to x, and this becomes. Now first finding the differentiation of this. In order to do so, you have to use certain rules of logarithms, which are these rules. According to this rule, the differentiation of the function ln x is 1 by x, and the second rule is the chain rule, which says that if your y is equal to ln of hx, then y prime is equal to h prime x divided by hx. That is, you first have to take the differentiation of log, which is 1 by x. Here your input is hx, that's why in the denominator you have 1 by hx. And then you have to take the differentiation of your input, that is hx. So that would be h prime x. Now using these formulas, your differentiation of ln x would be, note that here your input is ln x, so your differentiation would become 1 by ln x, and now you would be differentiating ln x, that is 1 divided by x. Taking limit, and the differentiation of x with respect to x is 1. So this becomes limit x tends to infinity 1 divided by x into 1 divided by ln x. Now if you substitute the limit, you will see that this becomes 1 divided by infinity into 1 divided by ln infinity, which is equal to 0, into 1 divided by infinity, which is equal to 0. But we had to find the limit of the expression exponential to the power limit x tends to infinity 1 divided by x ln of ln x. From the above calculation, we can see that the limit of the exponent is equal to 0. So your function becomes e to the power 0, which is equal to 1. Thus, the limit of the function x tends to infinity log of x to the power 1 by x is equal to 1, which is your answer.